Hello and welcome to Fabublox. In this video, I'll show you how we built the first of its kind collaborative R&D platform for micro and nanofabrication. See how we're not only revolutionizing documentation, visualization, and sharing of cleanroom fabrication processes, but also how we're on track to build the world's largest public micro and nanofabrication database by setting the first publicly accessible data standards in this field. So let's dive right in and navigate to fabublox.com. From the Fabublox landing page, we can immediately log in or sign up using an email address. This is securely done through Auth0 and takes only seconds. We can then jump right in and start designing a process. When we create a new process, we can always decide whether we want it publicly visible or not. We'll leave that toggled off for now and name our process. Now we're in the process editor UI of Fabublox. What we can see immediately is that our process will be built up in the center, starting from a substrate. The way we build processes is by adding blocks from the blocks library. Our blocks library currently contains about 30 commonly used micro and nanofabrication tools that span everything from common lithography tools to deposition tools, etching tools, and doping tools. So to understand how Fabublox works and what's special about it, let's build a simple lithography process. We will start by spin coating a photoresist. This adds a layer onto our substrate, and when we click on this block, we can see two key properties that are associated with each block in Fabublox. The first one is the experimental parameter sidebar, and the second one is a so-called stack action that allows us to auto-generate figures that constitute our layer stack. Let's start by talking about experimental parameter documentation. In micro and nanofabrication, it is of crucial importance to document a whole range of parameters at each process step that are specific to the tool used. For longer processes, this can be many hundreds of parameters, and each and every one of them affects the outcome of the created device or layer stack. As there are so many parameters to keep track of, and there's no standardized way of doing this, this is extremely time-consuming, and it's also very difficult to transfer any process knowledge to other researchers. In Fabublox, this is made easy as we provide a predefined parameter space that constitutes all of the parameters that are important for proper documentation of this very process step. In the case of a spin coating step, for example, at the very least, we want to know what resist we used, what film thickness, is it a positive or a negative resist, we'll get to that in a moment, what spin speed we used, and how long we spun for. Of course, everyone cares about different parameters, so we also have a custom parameter field that can be renamed and added in any value that one might want to record. Next, let's talk about the second most time-consuming part of process documentation, which is figure generation. Generating figures of the layer stacks we generate in a process is key in communicating our work with peers or superiors on other engineers that may be less familiar with this kind of fabrication. With the tools that exist to date, this always has to be done fully manually, and especially for very complex layer and device stacks, this can be extremely time-consuming, and especially in process development, adapting figures takes a lot of time. Now, let's see how we fully automate this part by algorithmically generating figures based on the real-life functionality of a tool and how it affects a layer stack. For example, if we wanted to pattern this resist that we spun coat in the first step, let's add a lithography step where we expose our resist, and then by putting it in the developer, we can develop out this pattern. The generated figures are customizable in the display tab of the parameter sidebar. Thanks to the fact that we developed this app in React and everything is generated algorithmically, any changes to our layer stack propagate through all of the figures and process steps in a process. Here we can, for example, change the layer thickness and the layer color. To show how flexible and powerful our figure generating algorithms are, let's do a quick lift-off process to generate, for example, metallic contact pads. In order to do so, we'll simply deposit a thin metallic film on top of this resist and then do a lift-off process. While this follows the logic of the process correctly, and this is exactly what would happen in real life, these are not really the contact pads that we wanted. This is due to the fact that we used a positive photoresist. These areas exposed to UV light will wash away in the developer when using a positive photoresist. The better choice here is a negative photoresist. As soon as we choose a negative photoresist, we can see that once again, we can represent what happens in real life. With a negative photoresist, the exposed areas cross-link and harden and do not wash away in the developer, and we finally get the desired contact pads. In process development, things often change, and we may decide that liftoff is not actually the way to go with. Instead of having to manually adjust our figures to this, we can simply explore a different process flow. For example, if we move this e-beam lithography step to the very beginning, everything still follows the correct logic except that the liftoff process now fails, which is exactly what would happen in real life since our layer is beneath the photoresist. So now we can just simply remove this liftoff process and we will instead insert an etch step, which now allows us to etch through the layer beneath. We can strip the photoresist. And now, of course, since we're doing an etching process and we still want our contact pads, we can simply choose a positive photoresist that we develop out to make these contact pads. There are many more ways to customize figures in Fabublox, and we won't go through all of them right now, but I do want to point out one more. In micro and nanofabrication, it is very common to purchase substrates that already have more than one layer on them. In Fabublox, this is simply done by clicking on the start block and adding layers as we please or as we purchased, and then customize the figure in whichever way we want in the common way that we've seen before. If we wanted to implement this new substrate stack in our process flow, we could, for example, simply delete this layer, and we can see once again everything propagates through. We etch through this layer that we now have on our new substrate stack. And for example, if this is something where we just want to create a structural layer and some patterning, we could select to only etch this partially and then create this new structure right here. We can now simply save the process that we just created and access it through the Fabublox app navigation in the top left corner. We navigate to My Processes, which takes us to a list of all of our private and shared processes that we've created, with a little thumbnail of the final structure to help us visually guide and navigate through our processes. We can now jump right back into our demo process to look into a few more advanced and collaborative features that we can use with this created process. One of the core goals of Fabublox is to make collaboration as seamless as possible. We believe that one of the biggest inhibitors to knowledge maintenance and transfer within groups, such as shared facilities, research groups, but also startups and mid-sized companies, is the fact that there's no privately shared databases with a standardized data structure of micro and nanofabrication processes. Thanks to the data standards inherently created in Fabublox, creating private databases is extremely easy and managed through the Share tab in our process editor. As soon as we click this tab, we can see all of the groups that we're a member of. We can decide which group to share a process with by simply toggling on and off visibility for that group. For any group that we leave on visibility, this process gets immediately shared to the private database of that group. Any member in this group can now view this process, duplicate it, and adapt it to their needs. Similarly, if we want to share a process with any individual, we can get the link by clicking this button and send them the link. Anyone with a link to a process can access it and duplicate it similarly as anyone who has access to the shared process in a private group. Processes that we share with private databases in groups or that are shared with others by us in private groups are accessible through group processes, and we can quickly see which groups these are part of. We can also choose to share processes publicly with the research community by simply toggling this private process button to a public process. This automatically adds this process to Fabubase. Fabubase is our public peer-created database that anyone in the world with a Fabublox account can access and contribute to. For example, if I wanted to learn how to make this transistor from Josh, I can simply click on his process. I will now see it in a read-only version where I cannot edit any of the parameters that I see, and I cannot change any of the blocks. However, I can duplicate this process, save it as a copy to my processes, and now adapt it to any of my needs. Last, we will return to our demo process to learn how we can use the context menu on each block in a process in order to export figures and to create a private library of tool recipes. First, if we wanted to export an image of our final structure, we can simply right-click this last step and click Export Image. With Export Image, we have multiple options. We can either export as a PNG or an SVG, but we can also very conveniently simply copy this PNG to clipboard and then repaste it in any document or presentation, which makes it extremely easy and convenient to communicate updates in meetings. Last, we will learn how to use Fabublox to create private libraries of our tool recipes. In the real world, a tool recipe, as opposed to the standard library in Fabublox, which are just templates for recipes, a recipe is essentially an instruction set of how to process a certain material in a standardized way on a specific tool. This now is a spin coating recipe tied to this spin coater in U12. So this is something that we would also like to save to a library in order to have these recipes available to us to reuse in new processes and to share with other researchers. In order to do that in Fabublox, the context menu can simply be used to save this custom block to library. We can add a description and save it to our blocks library, and it will now appear under My Blocks. If we add it to the process, we will also see that the name, the tool name, and all of the parameters that we saved are reproduced here. And it even saves the display parameters associated with it, and it reproduces the layer thickness and the green color that we custom defined earlier for this resist. This concludes our demonstration of the current version of Fabublox. Stay tuned for simulation and process version control features coming soon, and in the meantime, go blocks it.